Hello everyone, my name is Kamil, and in this video I'm going to talk about assignment 3 for Com 3132. So let's get started. Firstly, we are importing the necessary libraries for this assignment, and then we are fetching the image from this URL, and we are store it in a variable called response. And here we are printing the data of this image, which is basically binary data that we can see here. And of course it's unreadable for a human. And then we are uh, transforming the image or the data into a 3D array using NumPy, so it's easier for us. It's easier so we can visualize it. And as you can see here, we are plotting this image, and as you can see, it's a really nice Lamborghini. And for here we are basically checking if the color value of the the red channel and the green channel are the same. If yes, that means it's actually a gray image, but because it's not, it says false. And here we are checking the green and blue, so of course it's false. That means it's not a gray image. And the shape of this image is 140 for the height, 359 pixels for the width, and 3 means 3 channel, which is red, green, and blue. And here we are kind of stripping away the red color, and we are saving it in this input image array as a variable. And now we are printing this image. As you can see, it's now a white and black image. So in this section, we are basically adding a line in every direction, and then here we are creating our kernel or the filter, which basically we have 0 values, and in the center we have 1. So if we want to use this filter, that means it returns only the center pixel. And here we are copying the shape of this image, which is like the array, and we have it all zeros with basically empty. And as you can see here, when we compare the original shape and the pad array shape, we see that it has 2 more pixels on the top and bottom, because we added 1 here, 1 there, and left and right same for the width. And here we are looping for every valid position in the image. And then for this -2, it's because we are using it because the kernel has 3x3 size, so we need a space to fit it in. That's why we used -2. And this I and J represents the top left corner. And then inside this temp array, we are basically grabbing a chunk of this image, which is 3x3 size, and then we are multiplying this chunk by the kernel, which I showed above. And now when we print the result, as you can see, it's a gray, because of course we use the gray color map, but it's kind of gray. And in this part, we are defining a function, because as we know, the color range for RGB is between 0 and 255. So if the value of the pixel is less than a 0, it returns 0. Else if the value smaller than 255, it's return the value itself. If it's bigger, return 255, because the number should be between 0 and 255. And in this part, we are basically doing everything that I talked about and we define it into a function. Then here we have a horizontal kernel which detects the horizontal lines, and we are calling the function that we created above, and we are printing the result. And in this part we have a kernel for 45 degrees, and it's kind of highlighting, or the edge is kind of brighter when it has a diagonal shape. And here at the bottom we have for 135 degrees, but it's kinda these two, they look exactly the same, so I couldn't find the difference. So let's try a different type of filters. The first one, it results in kinda dimmed photo where we only see like a highlight of the edges. And the second one is more obvious, that it has mainly all the edges in the photo. And the last one here, we have clear edges, very sharp, very bright. And now we go to the part B. Same thing, we are importing all the necessary libraries, and we are splitting our data to train image, train labels, test images, test labels from this link. And we are loading the data here. Here we have train labels, test labels. We are changing them to one hot encode values, which means because we're using 10, then we have 10 classes starting from 0 to 9. All of them are zeros, but the correct class is gonna be 1. And then we are turning the color value from 0 to a decimal. Let's say we have 255 is gonna be 255.0. And then we are normalizing the range between 0 and 1 because we are dividing on 255. So black will be 0 and white will be 1. And then here we are building our model, as you can see, and we are compiling the model, and here the summary of the model. And this is uh, just like a logging kind of function. It just logs and it shows us the accuracy every 5 epochs. So when we start training the model, as you can see here at the bottom, it started the accuracy for training, it's 0.41, which is like 41%, and the accuracy of the validation is 50%, and it goes down till the end result when the accuracy reached for the training is 94%, while the accuracy for the validation is 63%. And after we plot the result, as you can see here in the chart, the model was start training, and I think here we have overfitting because as we can see here around like the epoch 20, the accuracy of the validation starts slightly dip down a bit, and it goes steadily but slightly down, which means our model start memorizing the data rather than just getting better results. And to answer this question, did the network present signs of overfitting? I believe yes, there was a clear overfitting starting around epoch 20 because, as we can see, while the training accuracy continues to rise, the validation accuracy slightly decreases. which indicates the model is memorizing the data rather than generalizing. How many layers this model has and identify their types. This model has 5 layers. We have the input layer, which conv to D, and 3 hidden layers, which were max pooling to D, flatten, and dense with ReLU activation, and the output layer was dense with softmax activation. So, to briefly explain what the purpose of each of these layers, we use the convolution. It's a feature extraction layer, and its job to act like a scanner that looks for patterns such as edges, textures, or shape in an image. Pooling layer, which we used max pooling TD. This is a downsampling layer. It reduces the size of the data to keep only the most important parts, and it also helps the model to run faster. And then we have the reshaping layer or flattening. This transforms the 2D grid into a long 1D list, so it can fit into the next layer. And then we have the dense layer. This allows the model to make high-level decisions because it connects every input to every output. And finally, the output layer. This is a classification layer because it squeezes the result to be between 0 and 1. And here I added one more convolution layer. As you can see here, I added a try in the middle, and after running this model, let's see the result. After adding the second convolution layer, it's kinda, I got the same result, but the accuracy is slightly better. We are around 70% or maybe a bit more, 71%. But also there is signs of overfitting as it goes from 71 to 68 and then it increases a bit. But still, the model overall improved. And to compare these two models, so the first model achieved a training accuracy of 94% and a validation accuracy around like 65%. The model shows steady learning behavior with only mild overfitting, but the second model achieved much higher training accuracy of 97% and improved validation accuracy, as we can see here, because it was 69%. And this shows us that the model is able to learn complex feature from the image, which result in better performance. However, the gap between training and validation accuracy shows that the model is memorizing the training data rather than generalizing to unseen data. And the last task for this assignment is to add a dropout layer to the model. So I added here a dropout layer which of 25%, and after running the model it shows that we had a really steady performance. So at epoch 15 we have a training accuracy of 64% while the validation accuracy is 69%. Then it keeps increasing till we get a slow dip down around epoch 45. And here, as you can see, they are both really close to each other, which kind of less overfitting, I would say. But at the end, it start also the validation accuracy to dip down. So to explain what is the dropout layer and what the purpose of the dropout layer, sorry about that. The purpose is actually to reduce the overfitting and improve the model's ability to generalize to unseen data, and it's basically works by randomly disabling the percent of neurons during training. So, for example, if the dropout rate was 0.5, that means 50% of the neurons are ignored, and this forced the model to not rely on a specific pattern and allow it instead to learn more complex features. And that's it for this assignment. Thanks for watching.